and welcome to another Unity 5 tutorial. In this tutorial, I'm going to show you how to build a blocky mesh in a procedural way. So in the past, I've made some Minecraft tutorials based on the Unity default cube. Now we're going to make that landscape from the Minecraft stuff into a procedural mesh so that it's actually more optimized for running in Unity. Because with all those single blocks in the other ones, and if you've been following along, you'll have noticed there's tremendous lag the bigger you create your chunks of land. But to do it properly, you need to do it procedurally. Now, the issue with a procedural blocky mesh is that it's not like a landscape where there's really only one vertex and you're lifting it up or down. You're actually adding a block onto an existing mesh, which is extruding it out of the surface. So you're creating vertices at the same time, not just manipulating them like you do with the terrain tool in Unity. So let's get started. I've created a cube, just a normal cube, and I've made it green because I felt like it. And what I've also done is I've made some code so that we can rotate this cube. So the idea is that we're going to click on any side of the cube and another cube will attach itself to it and it will become the same mesh. So this is just a default Unity cube. And I have put the green shader on it. Now make sure when you create this cube you put it at 0, 0, 0. So this whole idea of building this mesh up is based around units of 1. So this cube is unit of 1, 1, 1 and it's positioned at 0, 0, 0. Now the alignment of these blocks that then become part of the same mesh is exactly the same idea that we worked with in the other Minecraft tutorials. Right, so you've got your block. Now we're not running around with a first person in this one, so what I did is also create this script called rotate camera, which I have attached to the camera. You'll see down here, and I'll just show you what's in this script. It's quite simple. I've got an update loop. If the left key is pressed, then we're going to rotate in one direction. And we're rotating around, so the camera will continue to look at 0, 0, 0. So it's going to be looking directly at that center block while rotating around its up axis. And then if we press the right key, it will rotate in the other direction around its up axis. Okay, so you type that in and save it and attach it to your camera. Right, then when you run, you'll be able to use your arrow keys to rotate that cube around. Great. So the next thing we need is the script that will build our procedural mesh for us. So I've created a C# script called build block mesh. So you should create that C# script, and in it we're going to put this code. I'm going to begin in the update function and explain it for you first. So first of all, if the mouse button has been clicked, we then do a ray cast into our world and see if we've hit something. And if we've hit something, which is going to be the mesh because that's the only thing that's in that world, we're going to then determine our hit point. So the physics ray cast is going to shoot the ray out into the world through the screen, and it's going to return the object that we hit, which is going to be a game object. Now that hit object has a point that you hit at, and that's a 3D coordinate in 3D space. What we're going to do with that hit point also is we're going to grab the normal. Now I've talked about normals before, but just to refresh your memory, just bring up my little diagram and give you an idea of what we're going to do. So find sketchbook, here we go. Right, so this is our cube. We're going to click on it with the mouse. So let's say we click just here. This is the hit point and it has a coordinate in 3D space. Now the normal that gets returned is the normal to the plane that gets hit. Now remember, these cubes are actually triangles like that. So if I click here, I'm actually hitting this plane. The normal to this plane is a vector that goes at 90 degrees to the plane. Oops. You get the idea. Anyway, so it's this vector that's coming out here. The nice thing about the normal is that it actually points where we want the next block to go, because if we've clicked here, we want our next block to get built just here. Like that. Now, if we take the hit point and we add the normal to it, or part of the normal, then we're going to end up in this sort of region where we want that block to be. So we're going to take advantage of that in the code. So let me go back to Unity and open up our code again. Okay, so the position for our new block is being calculated using the hit point and then half of the normal. So instead of the whole normal, we're just going to take half of that so that we're somewhere inside the region where we want our next block to be. Okay, and then we're going to round off the X, Y, and Z coordinate that we get for our block position, because if I go back to the sketch, okay, if we add the normal to this hit point, we're going to end up somewhere inside of here. If we click over here and we add the normal, we will still end up somewhere inside of this block. Now, by rounding it off, it's going to round it back into the center position always of that area, no matter where we've ended up calculating inside of here. So just back in the script, you can see that I've done that with these lines here. I'm rounding into the center of that where the block's going to be positioned, so that it will be positioned perfectly in a unit 1 distance from the previous block. Now, because we're working in a 3D world and we can go into negative numbers and not realize we're there, and we start to do like ceiling and floor functions on those types of numbers, then you can end up going in the wrong direction with the rounding. So if we use this midpoint rounding away from 0, then that rounds it the correct way for us. Now, this particular round function I've used before. If this is the first tutorial you're watching, you won't be aware of this, but this is a C# library math. Math which is the Unity one, will work fine, but if you want to use the math by itself, which gives you access to this particular option, then you need to, at the top, include the system.collections library up there. Right, so that's rounding. We then create a new block. So we're instantiating a new block based on a prefab that we'll pass to our script, and we're putting it at block pos, which is what we've just calculated. We're then going to make our new block a child of the mesh, which is our initial cube, until we start building on it. Now, this is very important that we make it into a child, because the next step is going to look through our mesh and grab all of the children and combine them into the one mesh. So I've now written a combine function that we pass this block to, and you'll see why in a moment. Okay, so let's just scroll up to where that combine function is. Here it is. So the first part is to create an array of mesh filters, which are all of the mesh filters attached to our object, which is our initial green cube. And by running a get components in children mesh filters, it will return the mesh filter of the initial cube itself plus any children. And that's why we have made our new block a child of that mesh. So we'll now have 2 mesh filters that we're going to combine together, and we create a new combine instance array and essentially put our meshes into there, which is what happens down in this while statement. Okay, I've got a debug line in there that I was using to test how many mesh filters. At this point, the first time you run it, you'll see that you've got 2. We don't need that debug line, I'll just delete it. Okay, so we then loop through all of our mesh filters that we've got to put them into that combine instance array. And at the same time, we're going to set the game objects of the mesh filters themselves to inactive, which is important. We'll turn them on later on. This is all the individual mesh filters. So once we've added them in, we turn them off because we don't need them anymore. Once they're combined, they actually all disappear because they get combined into the one mesh. And you need to turn them off in order for your combine to work. All right, the next steps is that we create a brand new mesh. So we've got our mesh filter object that's attached to that first cube, and we're going to say equals a new mesh. And then we're going to create that new mesh using all of those mesh filters that we put in that combine array, which is this line here. We then do some recalculations of the bounds and the normals, and we run optimize, which is what you should do whenever you change your meshes in any way, if you're working with meshes procedurally like this. We then add a mesh collider, which is important because the mesh collider on the initial cube, which would be a box collider, is necessary in order for us to click on it in the first place. And then we set our mesh, our newly combined mesh, to active, true there. And then destroy the block that was created. Okay, so that's pretty much it. It's nice and short if you have a look at the code. There's only the update and the combine. Right, so let's go back to Unity and we'll grab this code and we'll drop it onto the cube. I don't think I've got it there yet. No. Okay, so I'll just drag this over to here. Now it's got a spot for our new block prefab that it's going to use to keep building blocks and blocks and blocks around here. So we can create a new cube, 3D object cube, and this will be our cube prefab. And I'll drag a copy of it and put it into the project to make our cube prefab. We can then delete it from here. Select the cube and take your new cube prefab and drag and drop it into new block. So that's going to get instantiated every time we click. Okay, so let's just run this. And we click. And wherever you click, you'll see that we can add a new block. Now you can see why I put the arrow keys in here to make it a little easier to add blocks. And it runs quite quickly. And if you go in and have a look at the stats on this, you'll see that you've got batches 1 here, which is really good because we've still got exactly the same mesh that we're building on and we're using the same material, which is quite obvious. Let me just shut that down and run it again. If we grab our cube prefab and just drop it in here, notice that it's grey. When we start adding cubes here, the problem is that that combined mesh function, it gives all the children meshes that you add onto what you're building the same material. So even though this prefab starts out as grey, as soon as we attach it to here, it just picks up the material of whatever's on the original mesh or the original parent mesh, which makes the job of creating different blocks in your world with different materials on it quite complex. And what I'm going to do is I'll finish this tutorial now because I've shown you how to build a blocky procedural mesh. In the next tutorial that follows from this, we're going to go into UVs and have a look how we can use a texture atlas like the one that you would find in Minecraft and divide up the UVs so that we can add blocks to here that have different textures on them but still have the whole thing as one mesh. And you'll still see in your stats that your batches will be very low, and initially they will be 1 while you still only got a few, because I'll still be using the same material but each part of the mesh can point to a different part of the texture on that material. All right, so have a little play around with this while you're waiting for my next tutorial. Hopefully I'll get that done very soon for you.